Two-year community colleges are a vital, low-cost entry point into higher education for millions of Americans. They can serve as a stepping stone to four-year colleges, and previous research has estimated that each year of completed coursework translates into an earnings bump of 5 to 11%. Yet, many of these institutions are plagued by poor student performance and low rates of degree completion and transfer to four-year schools. As a result, many studies have evaluated interventions targeted at students and aimed at improving academic performance. This paper approaches the problem from a different angle. Can we improve students' performance by targeting their instructors? To answer this question, the authors conducted an experiment covering over 6,000 student course observations at Ivy Tech Community College of Indiana. Ivy Tech is the largest singly accredited statewide community college system in the U.S. and serves nearly 170,000 students annually. Over 60% of its student body is eligible for Pell Grants, which provide financial assistance to undergraduates from low-income families, and only 24% of its full-time, first-time students end up graduating or transferring to a four-year institution within 3 years. During the 2016 to 2017 school year, the authors tested the effectiveness of implementing a performance-based incentive scheme at several Ivy Tech campuses. Instructors received bonuses of $50 for each student who passed an objective, externally designed course exam by scoring 70% or higher. Notably, these incentives were framed as losses. Instructors were paid upfront bonuses at the beginning of the semester that they were then required to pay back if their students underperformed at the end of the semester. To evaluate the causal effect of these incentives, their implementation was randomized across instructors. During the fall 2016 semester, instructors were assigned to either receive the incentives or not. In the following semester, the authors further added incentives targeted at students. Those who passed the objective course exam received free tuition for one summer course, an incentive worth approximately $400. In this part of the experiment, the randomization proceeded in two stages. First, the authors determined whether an instructor would receive incentives or not. Then, the sections taught by that instructor were randomly assigned to receive student incentives or not. Thus, the study ultimately comprised 3 treatment groups that received various combinations of instructor and student incentives, and one control group that received neither. This design allows the authors to evaluate 2 key questions. First, did instructor incentives improve academic performance? And second, were they more effective when paired with student incentives? This figure shows that instructor incentives had a large impact on the directly incentivized outcome, namely, student performance on the objective course exam. Relative to the control group, exam performance was 0.16 to 0.2 standard deviations higher in the instructor incentives group, and exam pass rates were 19% higher. Note that students who withdrew from the course, or who failed to take the exam, were coded as receiving a 0. Thus, incentives reduced course dropout rates, as well as improving students' performance conditional on taking the exam. The positive effects of incentives also carried over to course elements outside of the exam, indicating that instructors were not simply teaching to the test. The effects are largest amongst adjunct instructors, as opposed to full-time faculty, and importantly, there is no evidence that instructor incentives are more effective when paired with student incentives. These results indicate that instructor incentives are effective in improving student performance in targeted courses. But does this come at the detriment of students' broader outcomes? One might be concerned that students and instructors expended more effort in targeted courses, and thus underperformed in unincentivized ones. What the authors find, however, is that instructor incentives had large positive spillovers, and led to significant improvements in student performance, even in unincentivized courses. In fact, the impact is similar in magnitude to the effects in targeted courses. Overall, instructor incentives increased students' total credit accumulation by 18%, and when measured 1 year after the study's end, increased transfer rates to 4-year colleges by 22 to 28%, with no impact on 2-year college degrees. Thus, this paper provides evidence that instructor incentives can have large, persistent effects on student performance. What are some of the potential obstacles to implementing these policies at large? One significant concern is that the incentives in this setting were framed as losses. Recall that instructors received an upfront bonus that they had to repay if their students underperformed. While loss contracts can be very effective in motivating behavior, they are also generally unpopular. At baseline in this study, instructors significantly preferred gain contracts to loss ones and were willing to forego 9% of the incentive payment in order to work under a gain contract instead. However, after just 1 semester of working under the loss contract, incentivized instructors became close to indifferent between loss and gain contracts. This suggests that providing some experience with loss contracts may be enough to overcome instructors' aversion to them. Moreover, the authors calculate the expected cost of their incentive scheme to be only $25 per student course, indicating that this could be a relatively low-cost, yet effective way of improving student performance at community colleges. To read more on this topic, you can check out the full paper and its references to other related research. This includes previous work on the importance of college instructor quality, papers studying teacher incentives in the elementary and high school settings, research on the returns to a college education, and finally, papers on the effectiveness of loss contracts more generally.